Let's look at question number 3 for 2017 AP Calculus AB or BC free response. The function f is differentiable on the closed interval -6, 5. As we can see above, differentiable means f prime is defined for each of the values, and this thing is graph of f prime. So as we can see, f prime is defined for the interval -6, 5, or f is differentiable. And we know f of -2 is 7. F of -2 is 7, and the graph of f prime is shown above, and it consists of a semicircle right here and 3 line segments as shown in the figure above. We can see that. Now let's look at A. Find the values of f of -6 and f of 5. This is just the application of the fundamental theorem of calculus. What do we know about the fundamental theorem of calculus? How much well, to begin with, we know f of -2, which is at this point, is equal to 7. So if we can find how much the function changed by from -6 to 7, we can find the value of f of -6. What I mean, if we know the change in the function is 5 from -6 to -2, we know f of -6 must have been 2 because 2 plus 5 is 7. And we're gonna use similar reasoning to figure it out. How can we find change in function? Well, that's just the definite integral. So we know f of -6 and the change in function from -6 to -2 of f of x dx it has to equal to f of -2, which is 7. So we know f of -6 has to be 7 minus the integral from -6 to -2 of f of x dx. And what's the area from -6 to -2? We got a triangle going on with width of 4 and the height of 2. So the area of the triangle is 2 times 4 over 2, or 4. So we have 7 minus 4, which gets you 3 for the f of -6. How about f of 5? Same thing. F of 5 plus the integral from -6, not -6, we know the value of -2, -2 to 5 of f of x dx has to be, oh no, I'm messing this up, f of -2. You want to start at -2 and you want to go through some change. So f of -2, and you're changing the function from -2 to 5. That should get us to f of 5. We know f of -2 is 7, plus we know the area from -2 to 5. What's the area of the semicircle? Well, that's pi r squared divided by 2, and the radius is 2, so that gets us 2 pi. But since the f prime function is lying below the x-axis, we got minus 2 pi. You want to subtract it. And what's the area for this triangle? You got the width of 3 and the height of 2. So 3 times 2 over 2 gets you 3, and since that's above, that's going to be plus. So we got 7 plus -2 pi plus 3 also gets us 10 minus 2 pi for the f of 5. So that's our answer. Now let's go on. On what intervals is f increasing? That's easy to do. F increasing is synonymous with what? F prime is positive. And where is f prime positive? F prime is the graph of f prime is above the x-axis from -6 to -2. So from -6 to -2, and also where? It's also positive from 2 to 5. So 2 to 5. Make sure you do not put the close bracket. That's going to be the wrong answer. And the reason being, at -2, f prime is changing from positive to negative. So at -2, f prime is going from positive to negative. So you have a local maximum at -2. So you cannot say if it's increasing or decreasing at -2. So if you put the close bracket, that is not right. And you cannot put close bracket for -6 because you are not going to know whether the function is increasing or decreasing unless you know what's going on to the right and to the left. And since they do not give us anything to the left of -2, you cannot safely decide that the function is also increasing at -6. So you have to use open bracket for -6, -2, and for the same reasoning 2, 5. So that's the answer for B. Now let's look at C. Find the absolute minimum value of f in the closed interval. When we are finding an absolute minimum or maximum on a closed interval -6, 5, that's telling us we need to use the candidate test. And what do we do in the candidates test? We find the values where f prime is equal to 0 or undefined, and we're gonna look at the endpoints of the interval, and we're going to see which one gets us the lowest function value, and that should be our absolute minimum. We have when is f prime is equal to 0, we have f prime equals to 0 and -2 and 2. So we have candidates -2, 2, and the endpoints are -6, 5. So we want to find the value at f of -2, f of 2, f of -6, and f of 5, and compare them. We already figured out which ones. We know f of -6 is 3. Oh, that's 3. And we know f of 5 is 10 minus 2 pi. So f of 5 is 10 minus 2 pi. Do we know any others? They already told us f of -2 is 7. So let's plug that in. Now we gotta figure out f of 2. How do we figure out f of 2? We can go from f of -2, and you can put in the change in the function from -2 to 2 of f of x dx. And from -2 to 2, you got the area of 2 pi below the x-axis. So that's going to be f of -2, which is 7, minus 2 pi. Now, which one is the smallest? Well, pi is about 3-ish. So 10 minus 2 pi is about 4. And 7 minus 2 pi is going to be about 7 minus 6, which is about 1. So obviously, this thing is the smallest. So we can say the absolute minimum. Absolute minimum. Oh man, the writing is not working out today. Absolute minimum at x is equal to, what was it, 2 of what? Of 7 minus 2 pi. So that's the answer for C. Now let's look at D. For each of f double prime of -5 and f double prime of 3, find the value or explain why it does not exist. For f of -5, which is -5 is this point, you got a line segment. So all you have to do is find the slope of the line, and you know the line has point -6, -2, and it also has point -2, 0. So all you're doing is finding the slope. What's the slope? 0 minus -2 is 2. -2 minus -6 gets you what? Oh, am I doing this right? You got -2, 0 and -6, 2. Not -6, -2. So let's go this way. 2 minus 0 gets us 2. -6 minus -2 gets you -4. The slope is -1/2. So f double prime and -5 is -1/2. How about f double prime as 3? Hey, what's happening to f prime? You have a sharp turn. And when you have a sharp turn, you know f double prime as 3 is not going to exist. Not going to exist. And that's it.